Let us see the students. In the last time which we have discussed about the centripetal acceleration, at that time here I have written other method. Actually it is not other method but other formula of centripetal acceleration. We have got the equation of centripetal acceleration AC equal to v square upon r. I will repeat. Actually I have discussed this thing earlier in the earlier video lessons. The other formula. As you can see, the object is moving from P to P dash in the time interval delta t. Then you can see that this line CP is going to be shifting to CP dash. So it is going to be shifting by an angle theta. And this angle delta theta. So this delta theta is called what? Angular displacement. Then angular speed, actually this topic comes in the lesson number 7. The angular speed is defined as the time rate of change of angular displacement. So it is given by the symbol omega equal to angular displacement upon the time interval which is taken. So delta theta upon delta t is known as angular speed. Unit of angular speed is radian per second or rotations per second, or it is revolution per second. How many revolutions are completed? Just like as a fan. If you just purchase a fan, then on the box it should be written something like 1600 RPM, 1200 RPM, 1000 RPM. What is the meaning? 1000 RPM, that means 1000 rotations per minute. 1600 RPM means 1600 rotations per minute. So it is angular speed. The angular speed omega is delta theta upon delta t. If the linear now, as the particle goes from P to P dash, you measure this covered distance from P to P dash. So this covered distance P to P dash is known as linear distance. And this linear distance is also covered in time interval delta t. So if the linear distance travelled by the particle in time interval delta t is delta s, and this delta is equal to what? Arc pp dash, then it gives linear speed. So linear speed equal to linear distance upon time taken, delta s upon delta t. Now from the definition of the angle, you can see that this arc pp dash subtending an angle delta theta. This is the radius r. So according to the definition of angle delta theta equal to arc pp dash upon radius. So you can write delta theta equal to delta s upon r. Means delta s equal to r into delta theta. You substitute this in the equation of speed v. So speed v equal to delta s की जगह क्या आएगा? r into delta theta upon delta t as it is. But we know delta theta upon delta t is given by omega. That's why speed v is equal to r omega. So this equation shows relation between linear speed and angular speed. So linear speed v is equal to r into angular speed omega. And that v you put it in the equation of centripetal acceleration. Then you will get another equation. So AC equal to v square by r. Put v equal to r omega. So r square omega square upon r becoming r omega square. So there are two equations of centripetal acceleration. One is v square by r, another is r omega square. Now you can get the third formula by using the concept of again omega. So here we know very well, when an object completes one revolution, then the time taken by it is known as periodic time. So time taken by the object to complete one revolution is known as periodic time. And number of revolutions completed in 1 second is known as what? Frequency. So periodic time equal to always time taken upon number of oscillations. And frequency is number of oscillations upon time taken. That's why frequency and periodic time are inversely proportional to each other. So frequency f equal to 1 upon t. So now here we know angular speed omega equal to delta theta upon delta t. If this particle completed one revolution, how much delta theta? So delta theta will be equal to, for one complete circle, 360 degree. 360 degree, that means it is 2 pi. and delta t is what at that time capital T. So this is most important formula of angular speed. Angular speed omega equal to 2 pi by capital T. 1 upon capital T can be replaced by f. So this is another equation. So omega equal to 2 pi small f, or 2 pi by capital T. Now again you can get the same equation v equal to r omega by using this concept. And linear distance traveled in one's revolution is what? 2 pi. तो ये लेंथ आर्क पीपी डैश अगर पूरा आप कंसीडर करेंगे तो क्या होगा? लेंथ ऑफ सर्कमफरेंस ऑफ सर्कल. That's why the linear distance traveled in one revolution is 2 pi into r. So linear speed equal to again distance traveled upon time taken. पूरा एक revolution के लिए time कितना? कैपिटल T. तो 2 pi r upon capital T. Again 2 pi by capital T into r. 2 pi by capital T can be replaced by omega. So again v is equal to r omega or omega r. And then again you can write centripetal acceleration is v square by r equal to what? R omega square. Put omega equal to either 2 pi by capital T or 2 pi f. So r into 2 pi f square becoming what? 4 pi square f square r. And with this point, this topic is finished. Now let us see the one example. Example number 4.10 in your textbook. There is a one insect is going to be revolving on a circle having a radius equal to 12 centimeter and it completing 7 revolutions in time t equal to 100 second. यानी कि कितने से revolutions? 7 revolutions. इन कितने टाइम में टोटल? 100 सेकंड में. तो what will be periodic time? तो periodic time is equal to time taken upon number of revolutions. So it is 100 upon 7. And angular speed you may get omega equal to 2 pi by capital T equal to 2 pi by 100 by 7 equal to 2 pi into 7 upon 100. Becoming answer is 0.44 radian per second. From this you have to determine the centripetal acceleration of the insect. And then linear speed v equal to what? R omega. So linear speed of that insect is equal to 12 multiplied by 0.44 becoming 5.3 centimeter per second. It means insect is revolving on the circumference of a circle with linear speed 5.3 centimeter per second. Then what will be centripetal acceleration? R omega square. R is 12 into 0.44. So into 2.3 centimeter per second square is centripetal acceleration. Now the question is that does this acceleration is constant vector? No. At every moment from the point of a circle towards the center, the direction of centripetal acceleration. That's why centripetal acceleration goes on changing its direction at every moment. So direction of centripetal acceleration changes continuously. So it is not a constant vector, but its magnitude is constant and it is 2.3 centimeter per second square. Now I will start a new chapter, chapter 6, work, energy and power. Actually, what is the aim of this chapter? The aim of this chapter is to develop understanding of the meaning of these three physical quantities, work, energy and power. We know very well the meaning of work in our daily life. If I say if one student is doing a preparation of competitive exam by sitting at least for 10 to 12 hours every day, then what will you say? You will say he is doing a lot of work. But the physics is saying that he is not doing a little work. So from the point of view of physics, the work done by him is zero. So this is the difference between the meaning of work in our daily life and meaning of work in physics. You will study later on what is work. Now then what about the energy? Now suppose here I say some person or somebody is there who is doing a lot of work at least for 16 to 17 hours per day. That means he has a capacity of doing work at least 16 to 17 hours per day. And this capacity of doing work is said to be what? It's stamina. Or you can say what? It has a lot of energy. So meaning of this energy is nothing but the capacity of doing work. Then about the power. If you consider the game like a karate, boxing, so here we have to talk about the powerful punch. And this kind of the punch is delivered at a great speed. This shade of meaning is very close to the meaning of word used in physics like a power. So here in physics you will study the power is equal to the rate of doing work. So here we have to talk about all such three physical quantities in details: work, energy and power. But before we discuss that, we have to discuss one important topic which we have to make a use of it, and it is the scalar product of two vectors. So actually here we have studied in earlier lesson number 4 about the vectors quantities, scalar quantities. We have seen that the different vector quantities like displacement, velocity, acceleration, force, etc. Also we have studied in lesson number 4 about the addition of vectors, subtraction of vectors, but we don't have studied about the multiplication. In this chapter we have to study about how the two vectors can be multiplied, and after multiplying the two vectors, which resultant physical quantity we are getting. So actually there are the two ways of multiplication of vectors. One is known as scalar product or scalar multiplication, and this scalar product of two vectors gives us resultant physical quantity as scalar quantity from two vectors. And second is known as what? The vector product of two vectors. This vector product of two vectors gives us a resultant physical quantity as a vector from two vectors. And that vector product we will study in lesson number 7. At present we have to study about the scalar product of two vectors. So let us see the definition. What is the definition? The scalar product of two vectors is defined as the product of magnitude of the two vectors with cosine of the angle between them. That means if there are the two vectors like A and B, you take their magnitude of first vector, multiply with magnitude of second vector, multiply cos of the angle between them. So here it is also being known as dot product. Why it is known as dot product? Other name of scalar product is known as dot product because the scalar product of two vectors is denoted by placing a dot between the two vectors. So like A and A dot B, it can be read as A dot B. So this A dot B equal to magnitude of first vector into magnitude of second vector into cos of the angle theta between them, where you can say theta is the angle between the two vectors. I have shown here the two vector, one vector A, this is another vector B, they are in different direction, they are having different magnitude, and theta is the angle between them. This A dot B can also be written as simply AB cos theta. Now there is another definition comes. कैसे देखिए यहाँ पे. So now here from the head of this vector B, if I draw a one perpendicular line on the vector A, then I get OM. So OM is known as what? Projection, or it is known as what? Component. So OM is known as what? The projection of vector B onto vector A. Or OM is known as what? Component of vector B on vector A. On the other side, from the head of this vector A, if I draw one perpendicular line on the vector B, then I get OM. So OM is said to be what? Projection of vector A on vector B. Or it is known as what? OM is known as what? The component of vector A taken on the vector B. And we have to make the use of it. So OM is equal to A cos theta and OB will be equal to B cos theta. Because OM is equal to what? Adjacent side मिलेगी देखो right angle triangle में. इसलिए OM की वैल्यू कितनी? ये hypotenuse का वैल्यू into cos of the angle theta between them. So OM will be equal to B cos theta. Similarly OM, तो यहाँ पर भी right angle triangle है, यहाँ पे hypotenuse क्या है? Vector है, तो इसका magnitude into cos theta. So OM is B cos theta and OM is A cos theta. Now in this dot product, magnitude of vector A, magnitude of vector B and cos theta are the scalars. Since magnitude of A, magnitude of B and magnitude of and cos theta are the scalars value. So product of magnitude of A, magnitude of B and cos theta is also be a scalar quantity, and thus the dot product or scalar product of two vectors always gives us a scalar quantity. तो ये तीनों का प्रोडक्ट आपको एक नंबर ही मिलेगा, इसकी कोई डायरेक्शन होगी नहीं. That's why it does not have any direction. Then now we have another definition. Another definition come from this figure. Now A dot B equal to AB cos theta can also be written as A dot B equal to A into bracket B cos theta. What was B cos theta? B cos theta was OM. OM can be read as what? Projection of vector B on vector A. or it can be read as what? Component of vector B onto vector A. So thus A dot B is given by magnitude of first vector into component of the second vector B taken on the first vector. Similarly, A dot B equal to AB cos theta can be written as B into bracket A cos theta. What was A cos theta? A cos theta was A ON. So I write B into ON. What was ON? ON can be read as component of vector A on vector B. So thus A dot B can be written as magnitude of second vector B into the component of the first vector A taken on the vector B. So thus A dot B is the product of magnitude of the first vector A and component of the other vector B taken on the first vector A, or A dot B is the product of magnitude of the second vector B and component of the first vector A taken on the second vector B. Thus A dot B is equal to B dot A. So another definition of dot product or scalar product. Scalar product of two vectors is defined as the magnitude of any one of the two vectors and component of the other vector taken in the direction of the first vector. फिर से स्केलर प्रोडक्ट ऑफ टू वेक्टर्स इज डिफाइंड एज द मैग्नीट्यूड ऑफ इन दो में से कोई भी मैग्नीट्यूड ऑफ एनी वन ऑफ द वन वेक्टर and component of the other vector which is taken in the direction of the first vector. Thus vector A dot B equal to B dot A. It means what? It obeys the commutative law. Now there are the properties of the scalar product. First property, commutative law, vector A dot B equal to, you can write B dot A. Distributive law, vector A dot in bracket vector B plus C equal to vector A dot B first plus vector A dot C. We see the proof of this one later on. Then third properties, scalar product between the unit vectors. कौन से unit vectors? In x direction, the unit vector is, as I have last time explained, you consider this as x axis, this as y axis, this as z axis. X axis and y axis are perpendicular. Y axis and z axis are perpendicular. Z axis and x axis are perpendicular. Along the x axis, unit vector I. Along the y axis, unit vector G. So unit vector I and unit vector G are perpendicular. Along the z axis, unit vector K. So J, unit vector J and unit vector K are perpendicular. In short, these three unit vectors I, J and K are mutually perpendicular to each other. Perpendicular means the angle between them is 90 degree. Between unit vector I and J, angle is 90 degree. Between unit vector J and K, angle is 90 degree. Between unit vector K and unit vector I, the angle is 90 degree. But if you take the two unit vectors I in the x direction, तो दोनों के बीच का angle 0 degree. If you take the two unit vectors J in the y axis, तो दोनों के बीच का angle 0 degree. If you take the two unit vectors K along the z direction, तो दो के बीच का एंगल 0. मतलब दो यूनिट वेक्टर्स ऑफ सेम काइंड, then angle is 0. If you take the two unit vectors of different kind, then angle between them is 90 degree. On the basis of this fact, we know angle is 0, मतलब cos 0 is 1. And angle is 90 degree, so cos 90 is 0. On the basis of this fact, now you have a scalar product between the unit vectors. So unit vectors I dot I equal to J dot J equal to K dot K equal to 1. Why? Because I dot I according to definition, पहले यूनिट वेक्टर का मैग्नीट्यूड, दूसरे यूनिट वेक्टर I का मैग्नीट्यूड इनटू कॉस ऑफ द एंगल. एंगल कितना? दोनों I है, इसलिए 0. तो क्या मिलेगा? पहले यूनिट वेक्टर का मैग्नीट्यूड, दूसरे यूनिट वेक्टर का मैग्नीट्यूड, यूनिट वेक्टर का मैग्नीट्यूड ऑलवेज 1. तो 1 into cos 0 is 1, आंसर is 1. तो I dot I is equal to 1. Similarly, J dot J equal to 1. Similarly, K dot K equal to 1. So thus, in short, you can write I dot I equal to J dot J equal to K dot K equal to 1. But if you take the two different unit vectors, I dot J equal to J dot K equal to K dot I equal to, answer is what? 0. Why 0? Because I dot J equal to, here these are the two unit vector I along x axis, unit vector J is along y axis. तो क्या आएगा दोनों के बीच का एंगल 90 डिग्री। तो पहले यूनिट वेक्टर आई का मैग्नीट्यूड इंटू यूनिट वेक्टर जे का मैग्नीट्यूड इंटू एंगल दोनों के बीच का 90, तो कॉस ऑफ 90। तो पहले का यूनिट वेक्टर का मैग्नीट्यूड 1, दूसरे का 1, लेकिन cos 90 0, तो आंसर इज 0। तो बी रिमेंबर the dot product or scalar product between two different unit vectors is always 0, and scalar product or dot product between two unit vectors of same kind is always be equal to 1.